If you diagnose vehicle electrical concerns, intermittent symptoms that don't set any diagnostic trouble codes have got to be among your least favorite assignments. Fortunately, you can get help with a lot of them by using the Snapshot function of the Tech 2. Hi, I'm Jim Scopolitis. Today's Service Alert program focuses on Tech 2 Snapshot. As a bonus, we'll follow that with an important update on oxygen sensors from Delphi Engine Management Systems as presented by Chevrolet Pro Service News. Okay, Snapshot and how to make the most of it. Of course, the Tech 1 as well as the Tech 2 take snapshots, but the Tech 2 can do more with them. As you test drive a vehicle or merely wiggle suspect wiring under the hood, Snapshot allows you to record the changing data for every item in any single data list for any module that communicates with the Tech 2. In this example, it's the PCM and the Engine Data List 1. Unless you exit out first, Tech 2 software determines how long or for how many frames any particular snapshot will run. Back in the bay, you can replay the snapshot for help with diagnosis. Now, when do you need Snapshot? When you're diagnosing a symptom for which a diagnostic trouble code or DTC has been set, you follow the diagnostic chart for that code, of course. But when there's a history code that isn't current when the car comes in, or when no codes are set, and when there's an intermittent symptom that you may be able to recreate, then Snapshot can be a big help. For example, let's say the complaint is an occasional stumble or hesitation in a 1998 Bravada. The fault is too brief to set a code. You decide to take a test drive to try to induce the symptom and capture the fault on Snapshot. Now, the details of various Tech 2 screens will change from vehicle to vehicle and with some Tech 2 updates. But what you'll see here is close to what you'll see on any Oldsmobile. Before setting out, set up the Tech 2 to run the snapshot you want. You want a PCM snapshot, so you select the powertrain menu and under it the snapshot option. You suspect there's a circuit fault in some drivability input to the engine. So under the first snapshot menu, you select Engine Snapshot. Now the display lists the titles of the 5 PCM engine data lists available on the 98 Bravada. You think Engine Data 1 is the most likely. By the way, if you want to easily check what's in each of these engine-related data lists, remember that they're listed in the service manual at the very beginning of the engine section, along with typical readings for the inputs. When you select a data list, the screen changes to the Snapshot Options menu, which allows you to select a type of marker called a trigger and a trigger point. Okay, which type of trigger do you want? Because the symptom you're investigating didn't set any codes, and you hope to be able to recreate it during a test drive, you select Manual Trigger. This allows you to trigger the snapshot yourself when you think the fault might be occurring. If the problem had set one or more codes, you might select either any code, meaning the snapshot would be triggered when the first code was set, or single code. Selecting single code would move the display on to let you specify a particular code as the trigger. Now, the trigger point. When a snapshot is taken, the Tech 2 actually begins temporarily remembering data right from the beginning of the recording, but it doesn't mark any section of it for long-term storage until the trigger occurs. This arrangement allows the actual snapshot to be saved so that the trigger occurs at the beginning of it, or near the center, or at the end. Most technicians usually select the center trigger option. Once you've set up the trigger, you're ready to begin short-term recording by pressing the soft key underneath Record Snapshot. On the other hand, if you were ready to review a snapshot now rather than record one, you'd press the soft key under Review Data. You want to record, so with this screen still in place, you take the vehicle out on the road, and when conditions seem right, you press record. Now the beginning of your selected data list is displayed, with all its changing values. And at the bottom, the trigger soft key is waiting to be pressed. On the Bravada, Engine Data List 1 has 50 entries. You could scroll through them all, but you certainly couldn't notice much. Capturing this data so you can study it later is what Snapshot is all about. Instead of watching the Tech 2, your job now is to create conditions that might induce the fault and to press the trigger key when you actually feel the symptom or at least think it may have occurred. Now the Tech 2 stores the actual snapshot, beginning before and continuing after the trigger point. You can let it finish its own timing, or you can press the exit key to end it when you choose. After that, you could exit back to the Record Snapshot soft key and record a second one. The Tech 2 can store two. After each snapshot, the screen changes to Snapshot Replay, stopped at the trigger point, which is frame 0. Before you set all these values rolling, the Tech 2 offers you several ways to look at them. Because you could go nuts scrolling back and forth through 50 changing entries, Select Items allows you to select up to 5 of these items that might be the cause of the symptom and move them to the top of the screen so you can watch them together. This makes it easier to watch for abnormal readings during replay. But it's still no picnic. So the Tech 2 offers a real advance, the plot option, which allows you to plot up to 3 suspect inputs on a graph and watch them play back that way. We'll demonstrate plotting in a minute. Select Frame lets you move to a specific frame in your snapshot. And More leads you to more soft key options. Auto Reverse plays the snapshot rearwards in time. Auto Forward plays it forward. And pressing More again gives you other ways to move through the snapshot. Now let's exit back and select Plot. The available soft keys change to Accept and Clear All, indicating that you should now choose your items for plotting. To do that, select an entry, such as throttle position sensor voltage, and press Enter. An asterisk appears next to it, indicating that that item has been selected for plotting on the graph. When your 1 to 3 choices have been selected, press the Accept soft key. And here's your graph. The Tech 2 is showing you the record of coolant temperature voltage, throttle position sensor voltage, and TP angle during your snapshot. This particular section begins with frame 0, the trigger frame, and extends to frame 25. To go beyond frame 25, or to see what happened before the trigger point, you would step forward or backward through the snapshot using the Move soft keys with arrows. Now, how do you tell these traces apart? The key is down here. The thin, unbroken trace shows engine coolant temperature sensor voltage. The thin, broken trace indicates throttle position angle. And the thick trace indicates throttle position sensor voltage. The information above the key indicates the minimum and maximum values shown by these inputs during the entire snapshot. For example, this thick line tells us that the minimum voltage read from the throttle position sensor was 0.47 volts, while its maximum reading was 0.86 volts. What else? Oh yes, the specific values shown in the lower right-hand corner indicate the exact readings from these inputs at the frame indicated by the broken line down the center of the graph. Obviously, plotting a snapshot on the Tech 2 can be a terrific help in spotting readings that are out of spec. but you can see what you're looking at more easily and do quite a lot more with it if you replay it on your Techline equipment. Let's say you return from your test drive in the Bravada with what should be a good snapshot and connect the Tech 2 to your Techline equipment to replay the results there. The reference guide for this program gives the key steps for doing this. By the way, a big advantage of the Techline computer is that, except when you're plotting, it can display a whole data list at one time with no need for you to scroll through items. It also gives you lots of easy-to-use icons. An illustration in the reference guide explains what they can do. What you want to do now is plot 3 inputs on a graph, so you click on the icon for Display Graph. Based on your experience of the symptom during the test drive and on similar cases in the past, you suspect the mass airflow sensor circuit. So as your graph parameters, you select mass airflow grams per second, mass airflow frequency, and as a third item, TP angle. Now it's easy to see the 3 inputs in their different colors, and you can play the snapshot through, remembering how you drove and watching for glitches. You can stop playback at any point. If a particular trace varies too little or too much to show clearly what's happening, you can change the scale for that input to a more appropriate range. As playback approaches the trigger point, you notice a sudden brief fall off to 0 in both mass airflow grams per second and mass airflow frequency, exactly the kind of momentary fault that might cause the engine hesitation you observed. Plotted on a graph, it becomes very easy to see. You now have proof of an intermittent problem in the mass airflow sensor circuit, and you need to locate the fault as usual. By the way, a Techline computer allows you not only to save your snapshot, but to print out a single frame of it, like this one. And whenever you need to return to a snapshot on either the Techline equipment or the Tech 2, the software will probably show you 2 to choose between. You can tell which one you want by checking the vehicle details and the date and time of the test drive in question. There's more that you can do with a snapshot. In a really tricky case, you can even send a snapshot to TAS for help with diagnosis. But that's all we have time for now. Our thanks to Delphi and Chevrolet Pro Service News for the following segment on oxygen sensors. Stay tuned for that, and I'll see you next time.
When's the last time you heard of zirconia? I bet it was on one of those shop-by-TV shows selling cubic zirconia that looked like diamonds, wasn't it? Well, today, we're going to talk about something else made of zirconia. No, it's not jewelry, but it's valuable nonetheless, because engines won't run properly without it. I'm talking about the oxygen sensor, of course. First, let's take a quick look inside. Just like a spark plug, an oxygen sensor has a lot of ceramic components in it. The zirconia ceramic tip extends out into the exhaust stream. There's also a ceramic insulator, a ceramic heater and sleeve, and a ceramic insert. They're all housed in a metal shield, where you'll also find the entry point for the electrical wiring harness. Those ceramic components are easily broken if the O2 sensor is dropped, so you've got to handle them with care. Here's a cutaway of an oxygen sensor, showing the zirconia element with the electric heater inside. When the sensor is cold, the electric heater causes the zirconia element to reach operating temperature more quickly. As the sensor warms up, it begins creating a voltage. The amount of voltage depends on the difference between the oxygen inside the sensor and the oxygen in the exhaust gases outside of it. This galvanic action, in effect, makes the oxygen sensor behave like a little battery. Then the PCM receives the voltage from the sensor and interprets it as a rich or lean exhaust. It uses this information for fuel control and diagnostic purposes. While we were gathering information for this story, we talked with some engineers at Delphi E. They told us that the oxygen inside the sensor is there from when it's manufactured, and that the housing of the sensor is sealed, so you'd think nothing could get in or out. This setup demonstrates that air expands when it gets hot, which happens inside the O2 sensor every time the engine is run. So the sensor breathes through the wires. Because the electrical connectors are environmentally sealed, the air flows all the way to the PCM connector before it finds a place to escape to the atmosphere. Then, when everything cools down, a partial vacuum is created, up to 9 psi, which draws air back through the same path. Well, this is okay, unless moisture happens to get in with the air. This could happen if a connector seal or the wire insulation is damaged. The galvanic action of the zirconia element quits working properly in the presence of water, so the O2 sensor signal becomes erratic, and the PCM sets a diagnostic code. When you unplug the sensor connector, be on the lookout for moisture. There may be just a little, like this, or a lot. Over time, even a little water will cause the terminals to corrode, leaving a visible deposit. The only thing you can do at this point is replace the O2 sensor. But don't stop there, because the problem is only half solved. You have to locate and eliminate the leak, or the condition will quickly return. The engineers told us that they've seen wiring that's been damaged by chafing against metal parts, or even melted from contact with the exhaust. This kind of damage is usually caused by missing or improperly installed harness clips. If the damaged wire is between the connector and the O2 sensor, it will be replaced along with the sensor. But if the damage is in the harness on the other side of the connector, you need to locate and repair it. The only acceptable repair is the crimp and seal connector found in your J38125 Packard Terminal Repair Kit. Cut the wire at the damaged location and strip the ends. Insert the wire into the splice until it bottoms, then crimp it. Repeat with the other wire. Now, use the ultra torch in the kit to heat the splice until the wrap shrinks and glue melts out of both sides. Do not use any other splice, and especially do not, repeat, do not solder the connection. Doing so will impede the air path through the wire. Here's another thing you must not do. Do not install any kind of grease into the connector, not even dielectric grease. Grease will migrate down the wire and contaminate the inside of the sensor. Even a little bit is catastrophic. Complete your repair by checking that all clips are properly installed and that the wiring is not chafing or contacting any hot parts. Then you can confirm that your repair was done properly using your Tech 2. Start with the ignition turned off. Taking the key out is a good way to be sure. Hook up your Tech 2 and program it as far as you can without having the ignition on. Now you have 2 minutes to complete the procedure once you turn on the ignition. So you should quickly finish programming your Tech 2 to bring up the data for the oxygen sensor. At first, the voltage should be between 425 and 475 millivolts. Before 2 minutes have passed, the reading should increase or decrease 150 millivolts from the initial voltage. If it is, you've shown that your wire repair is good, that the O2 sensor heater is working, that the sensor is good, and that the PCM is receiving and displaying the data. If the reading is not within these specs, you'll have to follow established diagnostics to locate the cause. This brings up another point. All of the diagnostic procedures in your service manual contain numerous steps and call for numerous checks and inspections. Never skip any of these steps, because the thing you skip may just be the thing you need to find to correct the condition. Have you ever been embarrassed by replacing the wrong component? Well, it happens, but probably only to the guy in the next repair bay, right? Well, you may want to remind him that Bulletin 676540 was published to help identify which oxygen sensor is located where. Remember, on OBD2 engines, there's one ahead of and one behind each catalytic converter. That means V engines can have up to 4 sensors. On the subject of bulletins, 670502 reminds you to include P codes, technician observations, and customer comments in the comments section of the warranty claim to help GM powertrain engineers understand the reasons that cause mill lamps to illuminate. And finally, here are several installation tips. The factory applies an encapsulated locking material to the threads. Never add anything before installing a new O2 sensor. Always use the correct wrench when removing or installing an oxygen sensor to avoid damage. And always observe the service manual torque specification. Our thanks to Steve Mahan and David Leemaster at Delphi E for helping us bring you this story.